Welcome to a short update video on sea lice screening modelling. In this video we're going to cover sea lice particle tracking modelling and the analysis and visualisation of modelling results. We'll speak about what screening is and what models we've used, and then we'll show some results, tell you how we've analysed them, and then give some information on what the results are telling us. Screening modelling is something we do for many permit applications for aquaculture sites. It gives us an initial look at the aquaculture site and allows us to evaluate the risks. Often what we do is we use that information from screening modelling using an approximate model to scope out the more detailed modelling that we need for the final permit application. So we do screening at the moment for bath medicines and solid material from the farm. We are being asked to extend this to sea lice. The models we've used to do the sea lice screening were built by Marine Scotland. We've translated these models from the original modelling system to our own modelling system and modelled a range of aquaculture sites in different areas. All of the models are 3D. They use 10 layers to represent vertical processes in the water, and they are driven by wind and tide and freshwater flow under average conditions. In the case of the Firth of Clyde model, we used the model to model 20 aquaculture sites. Moving further north, we used the wider Loch Linnhe system model to model 42 sites within the model area. The final model we used was the East Coast Lewis and Harris model, where we modelled 102 aquaculture sites. So, modelling for sea lice involves a number of steps. First, we calculate the water flow over a period of time. In this case, we're calculating the water flow around a period of 2.5 months of model time. As I've said, we use average tide and wind and other factors to calculate the average water flow during this period of time. We take those calculations and then release virtual particles into the water flow fields and track where they move. Each site is modelled individually, so we put in a number of particles over time, and these particles are trying to represent the pathways and the destinations of the sea lice that are released from the farm. Once that particle tracking modelling is complete, we can analyse the particle tracks to work out where the sea lice are, or the particles that represent the sea lice are, and we can then use that to calculate the concentration of sea lice in different areas. This animation shows some output from one of the models, the Firth of Clyde model. On the left, the thing to focus on is the red and yellow particles that are moving around in response to wind and tide and freshwater flow. The particles, or the cells that are coloured in here, the model cells that are coloured, are made up of very many particles all released from the different sites. So at each point in time within the model, we can count the number of particles from all the different sites and add them up to complete a picture of where the lice are in the system over time. So this is the modelled lice. What we can do is use the particle tracking output to do various analysis on what that might mean for wild fish. So one thing that we've done is we have used a virtual fish track method to try and work out what happens when a fish moves through the clouds of particles that are used to simulate the lice. So on the right in this animation, they were showing the pathway of a fish as it moves down a loch system, out of Loch Fyne and into the wider Firth of Clyde. And you can see that at different points in time, it's exposed to different levels of modelled lice concentration. So this is quite a powerful method of trying to assess what the exposure of a fish might be within the model. As you can see from the left hand side here, the lice are not evenly distributed. There are areas of high concentration and low concentration. So the pathway that a fish takes through a system is quite critical. In this example, we're looking at the fish track analysis that we've developed for the Firth of Clyde. What we can do is put together a number of pathways and then send many virtual smolt fish down these paths and look at the statistics of the concentrations that they absorb as they move through the system. So this is a map of the different pathways, and each of those can be analysed to look at various statistics such as the median concentration or the extremes of the virtual smolts that pass through the system. So we can see that different pathways give different results, different levels of exposure on the fish. So as the fish are moving through the virtual fish are moving through the system, they are accumulating lice to give an overall lice per meter squared over a number of days. The one thing we can also do is we can look at the analysis of which sites contribute the most to the modelled outputs. So what we found is that not all sites contribute equally to the exposure that the virtual smolts experience as they move through the modelled lice. So this is quite a useful tool for identifying the relative risk of different sites. We've also done this analysis in our wider Loch Linnhe system model output. This is giving a different picture. There are many more sites in this area, and the oceanography and the mixing is quite different. But we're able to do the same type of analysis where we can have multiple different pathways, look at the statistics associated with them, and then also gain an insight into the contribution from each farm within the area. This is in development and there is more work to do. In particularly, we can actually use real fish data when and if that becomes available to further define the pathways and make them more accurate. We've also been looking at the model output data in a package called Spotfire. This allows us to produce interactive maps and other analysis which look at the data in a different way. I'm just going to switch to the package to just give you an idea of the type of things that we're doing. This is a map in Spotfire of the average sea lice modelled concentration over a period of April and May, so 2 months. On the map we see the water bodies that have been highlighted as wild salmon protection zones in red. We have the sites that were included in the model as green dots. The size of the dot is relative to the size of the peak licensed biomass on the farm. And the shapes in the water areas are output from the model, and these triangular grids are the grid cells within the model, which is where we make the calculations of water flow, but we're also counting the particles that are in those cells as an average. So it's a fairly simple analysis of where the particle concentrations are high and the modelled sea lice are high and where they are lower. We're finding this is a function of the number of sites that are in an area, but also the amount of dispersion that a model predicts within a zone. As we move down the country, we can see that the variations do have quite a different distribution place to place, and this is information that gives us an insight into the potential areas where we might need to focus on with detailed modelling. Moving down into the Firth of Clyde, you'll be able to see that the concentration map is very similar to the animation that we showed earlier. We don't have fish tracks for everywhere yet, And so what we also have done is tried to do a simple analysis of the average concentration and what it means in each of the wild salmon protection zones. Additionally, we've tried to estimate the contribution and the effect and influence of each farm within a zone. This is another Spotfire app where the wild salmon protection zones are highlighted alongside the different sites that we've modelled. What we're trying to do here is come up with a basic risk assessment of the concentrations in each of the water body zones and what that means potentially for the risk to wild salmon from the modelled output. What we've tried to do is calculate the different times that it potentially takes fish to move through the different zones. In reality, fish will move from rivers to sea, but what we're trying to do here is look at the travel times and the fish travel times through particular water bodies that have been identified. On the left in this map, we have a coloured water body system showing different concentrations of lice per metre squared in various areas. So the lighter and sort of bluer, the lower the concentration, moving to a more intense colour scheme with different colours as the concentrations increase. But that doesn't give us a full picture of risk. Concentration is not the only factor involved in the potential exposure of wild fish to sea lice. Another thing that matters is the travel time, the swim time through an area. And we have calculated that in a very basic way, using a fixed speed. And what we've then done is try to do a simple risk assessment, which is to take the concentration and multiply it by the swim time in days. So the concentration is a hazard to the fish, and the swim time is a measure of potential likelihood of them being exposed to high levels of lice. So the longer that they take to go through a water body, the more likely they will be to be exposed to more lice. When you multiply those two values together, you get a relative risk ranking. And this is just a first attempt to try and understand where the risk might be higher than others. On the right is a map of that risk ranking. And what's standing out immediately is that there are a number of areas such as the Firth of Clyde, Loch Linnhe system and this area to the north of Skye, which have a higher risk rating than others. This is just an initial look at the problem. It's a first pass potential indication that we may need to focus on these areas more than others. We can also rank the water bodies in order of risk. So this is a bar chart of risk ranking with the most risky water bodies to the left, moving to less risk in the right. And what we've tried to do is look at the distribution of these numbers and classify different water bodies into bands of risk. For instance, if we look at the highest risk band of water bodies, we can highlight that in the ranking and then move to the map. And Spotfire allows us to highlight these areas and give us the risk ranking in terms of numbers. So as you can see, it's picking out the areas which generally have high concentrations, but they also have fairly long swim times due to the length of the water body. Again, this is a very first attempt to try and use some available information to get a handle on where might be risky than others. There's a lot more information to consider when coming to a final view on risk, and modelling is only one part of that. However, using Spotfire does allow us to do things in a way which means that we could change the risk values and the thresholds and look at what that means in terms of the various water bodies. So it is very flexible if we want to change criteria for looking at risk. So in summary, we've made good progress on an initial round of screening. So we've modelled a lot of sites over a large area in a very consistent way. But these are approximate models, and what we're trying to do with them is understand where risk might be high so that we can target the effort on these areas. Developing the fish tracks has been a really useful process, and we're getting feedback on that process and refining it, as we are with everything. And I think that we've got this initial risk assessment, which can be the first stage to move on to looking at where more detailed modelling will help us get a better handle on the exact risk. We've learnt that fish track analysis and risk analysis can help us. I think it has helped us develop an idea of where we go next. We've also learned and shown quite clearly that not all sites are contributing the same. And so where a site is in the future, whether it's a new site or an increased development, where it is really does matter, and hopefully our screening will allow us to identify which sites are going to need quite a lot of attention and which sites will need less. I think it's clear that the modelling is at a certain scale, which is not very small and not always appropriate to the very detailed information that we read. And it is true that some aquaculture sites, particularly in the areas where we're looking at the highest risk from screening, are going to require detailed modelling beyond the screening level. That's the end of this short update video. Thanks very much for your attention, and please get in touch if you'd like any more information. Thanks also to the team and everyone who's been involved in this work so far.